Hey everyone, welcome back to my daily coding series. Today's day 68. So I just filmed yesterday's episode because I just moved back to school. So my schedule's been a little chaotic recently. So I just did this one, subray sum equals k. So let's see what problem I could do today. I'll try baseball game. So I'm going to do an easy problem today. Just because I just did a medium one. So hopefully this one isn't, hopefully this is a good level of challenge. So I'm going to try to solve this one. My goal is going to be 20 minutes, but I'll go up to 30. My goals are to not optimize too quickly and to not overthink things. And, sometimes just kind of take risks and code something that I think works. Okay, so that being said, let's read it and try to solve it here. So this is baseball game. You are keeping the scores for a baseball game with strange rules. At the beginning of a game, you start with an empty record. You are given a list of strings operations where operations of I is the ith operation you must apply to the record and is one of the following. So we're going to have like commands or operations basically. So we could have an integer, which is a new score. We could have plus, which is we're going to add a new score that is the sum of the two previous scores. D, which is record a new score that is the double of the previous score. Okay. And then C, invalidate the previous score, removing it from the record. Return the sum of all the scores on the record after applying all the operations. So we get operations and we must return a number. So when it comes to data structures and how we want to store this, so we're basically going to be given us just a flow of operations, and every operation accesses at most the previous two scores. So if we get an integer, we don't need any data. If we get plus, we need the previous two scores. If we get a D, we just need the previous score, and C, we need a previous score as well. So yeah, so that's so I'm thinking we'll just have two variables called like we could have maybe just like previous scores, and then it could just be I could say like last score and like I don't know a good name for it. So it's like last score and then like last score, which obviously isn't a good name. Yeah, we could just say previous score 1 and previous score 2. So previous score 1 will be the newest score. I could also call it latest score, and then like, well, previous, there's not really a good English word for like there's like penultimate, I guess, but that's kind of confusing. All right, I'll just say previous 1 and previous 2. I think that's probably communicates good what we want. So we're going to have these two variables, which will store the previous two scores. Okay, but there is some tricks. So C, so what if we invalidate our previous score? So that would invalidate this, and then we call plus. So would we still have to remember what previous 3 is? So let me look at the examples here and see if that ever happens. It doesn't look like it. So I'm looking for a C followed by a plus sign. So my question is, can we assume that when plus is called, the previous 2 scores will always be valid? That is my assumption. Or that is my question. So based on how they're doing it, so they add 5, then they add -2, then they add 4, then they invalidate the record. So it looks like in this example we have C and then D. So we may just need to store all of the scores in case we just C a bunch of times. So my question is, when plus is called, will there always be 2 valid previous scores? Because, okay. So yes, this talks to those assumptions here. So there will always be at least 2 previous scores, but my problem is, so if we had, let's say our scores were 1, 2, 3, 4, 5, if we called plus, obviously we would just add a 9 because that's 4 plus 5, but what if we called C, 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 or I guess 3 C's and then plus? So really what then should happen was it would be 1 and 2, these would all be invalidated, and then the plus would make it 3. So because we can call, I guess like n minus 2 C's, we need to store every score in the data, and we can't just use 2 variables. Yeah, I mean, so this kind of seems to me like you could use a stack because you want the previous scores. So what I mean by that is you would have a stack. So I'm going to, yeah, so I'll just walk through one example basically, but you'll have a stack, and every time you have a score, you'll just add it to the stack, and then C will pop from the stack. So I'll walk through one example, and then I'll start coding it here because I don't want to overcomplicate it, and I'm pretty sure that will be good enough for this problem. So our stack would be 5, 2, and then C would remove 5. Then we call double, so that'll add the top of the stack plus 10. And then plus would give us 15. And then we would just sum. We'd also probably want a variable that just is the sum. So instead of summing everything at the end, we can just do it while we do the operations. So the only thing is, typically with a stack data structure, you would only be able to look at the top element, but we'll just modify our stack so that we're allowing us to look at the top 2 elements here. So let's start coding it up. So we'll have a stack and a sum, which I'll call result. So we'll say for op in operations, I'm just going to have it be if statements. So we'll have if operation equals plus, elif operation equals, and okay, so another question, are we only going to have these operations? Like, could we ever get, for instance, x, or not x, that's like, could we just get a as an operation? Do I have to check for invalid? String representing the integer. Okay, so it looks like I don't have to check for invalid responses. So we'll check, is it a plus? Is it a D? Is it a C? And then otherwise, we know that it's an integer. So in the case where it's an integer, we'll just say stack dot append the integer of op, and then we'll say result plus equals op. In the case that we have a plus, we'll look at, so we'll say new score equals stack of -1 plus stack of -2. So these are the last two elements. And also we're going to assume that stack always contains integer values, so we don't have to check anything there. So that'll be the new score, and then we'll add that new score to the stack. So we'll say stack.append new score, and then we'll say result plus equals new score as well. Yeah, so that should work. And for D, we'll just do very similar logic here. So we'll say stack dot append. So I have an idea of how to optimize this, but I'm not going to optimize too quickly because that's one of my goals. So we'll say new score equals the previous element in the stack times 2, right? Because we double it. And then we will say stack dot append new score and res plus equals new score. And now for C, we'll say stack dot pop. And then also, so I'll call it removed, and then we'll say result minus equals removed. And then at the end, we will just return result. So let's try that. We're at 11 minutes. I have to typecast it to an integer here. So let's see how that looks. So we passed the test cases. Let's see if we got it. Okay, so we did solve it. So now I'm going to optimize it now. So I'm noticing here where the only thing that's really changing is so these are all similar in that, so these three, we're all adding something to the stack and incrementing result by a score. And this one, we're incrementing it by a negative score. So I think what we can do instead is probably maybe say if operation does not, I guess we could say if it equals C, then we'll do something, otherwise, and then we'll check these three conditions here. Okay, so my idea here was we'll have new score is stack of -1 plus stack of -2. Here, new score is equal to just stack the previous one times 2. And then here, new score, we can say is just equal to the int of operation. And then at the end, we can say stack.append new score, and then result plus equals new score. So that was my idea, is that the only thing that really changes between these is just what the new score is. But in each case, we append it to the stack and add it. So the only thing that's different is here. So we say we have to remove something from the stack. But we could say that new score equals -1 times removed. So then when we add it, that'll be the same as subtraction. So that's honestly might be less readable. But it does remove a lot of the duplicated lines. So it's this part is the only part that's not readable. I could just put it here and then say result minus equals removed. That might be more readable, so I'll just keep it like that. Okay, so let's try that. Probably should have done the run first. Okay, and that made a big difference, I guess. Yeah, sweet. So that was baseball game. That was 15 minutes. So that's pretty good for an easy problem, I think. I wasn't optimizing just for time. I also was optimizing for my thought process and my approach as well. So okay, so that's day 68. So I'll see you guys tomorrow, and thank you for watching.